Welcome back to the Fuse Show, everybody. My name is Jim. I'm the co-founder of Xfusion.io and the co-host of the Fuse Show. I'm excited to be joined by my guest, Dr. Gerald Friedland. Gerald is a CTO and co-founder of Brainome, and he teaches as an adjunct professor at the Electrical Engineering and Computer Science Department of UC Berkeley. Before that, he was a principal data scientist with Lawrence Livermore National Lab after being with the International Computer Science Institute for 10 years. Welcome to the show, Gerald.
Hello. Yeah, thank you so much for having me. Hi, Jim.
Nice You're welcome. So I want to kick right off into this. I did some research ahead of time, and I see that you started programming at the age of 7. Like, yeah, I honestly don't I could talk at age 7. I could maybe start to read, but I certainly wasn't programming. So I'd love to hear that story. Like, what were you working on, and what drove your interest?
Yeah, so this was actually a very interesting story. Actually, it's kind of funny. I like to reference Netflix shows. Right now on Netflix, there's this like $1 billion code show where there's these billionaires who basically, built Google Earth before actually something that is like Google Earth, except Google Earth did it 10 years later, and there was a huge lawsuit and so on. But the show actually, the more interesting part is this coding guy is very much like me. So we had in the beginning 80s. We had the Commodore 64, we had a Commodore 16 and all these computers, and it just piqued my interest. It was basically sitting in the basement. Nobody used it. My mom bought it from Aldi, which is like a discounter in Germany. No idea how she got to that, but it sat there in the basement. Nobody used it, and my dad gave me this book, and the book was also in English, but it was like some things were in italic. Right. And the things that were in italic were the basic instructions that you should type in so that something happens. And now you can see a 7-year-old taking, first of all, for 4 lines of code, probably an estimated 2 hours to type or something, because I was looking for the P the whole time, for probably half a minute each time, and barely knowing how to read and write, definitely not knowing English because it was German. But then after having done this mega task of putting in 4 lines of basic in the computer, something happens on the screen. That is obviously the most rewarding thing for a 7-year-old. And then I wanted to have this, I don't know, whatever, rewarding system in my brain got activated. I wanted to have that again. And so then I put the same program in again because I didn't know how to save. But this time I made some mistake. And now something else happened. And so what happens is over the time, I started to manipulate the program and to figure out what each of the commands meant. So I basically learned programming like somebody learns to decipher a foreign language or something that nobody speaks. And it turns out, first of all, it's a good way to learn programming by trying and error. That's actually how people learn really fast. But also, it kind of made me, really sort of, it trained me to the scientific process pretty early. And since then, I've applied it to a bunch of things.
That's so good.
That's how it started. Yeah.
That is so neat. I want to kind of circle back to that, but this is a natural segue since you brought up science, and I want to read a quote to you from, I think it's actually your page on the Berkeley site. But you said, quote, "Science is not just a job for me. Science is my passion, a life dedication, a devotion to overcoming political, societal, monetary, and historical biases and accepting nothing else but the one shortest observation-based explanation that minimizes the amount of ambiguity and contradiction. This is my definition of the truth." Now, I recognize you probably wrote this some time ago, but I'm wondering how you employ this in your daily life to overcome biases.
I am absolutely still 100% behind this statement. I mean, I sometimes call myself a science fundamentalist. Really, I will take science over anything, including over, it can get me into trouble, but including over scientific over political rules and stuff, right? I mean, that's obviously also partly why, people may find that strange, but why I emigrated into the US, why I came here, mostly because you can be yourself, and freedom is a big part of this. And so I have the freedom to apply science. Now, telling other people to apply science is, not like a one-shot thing, as we know, especially if you look at, vaccination rates and these kind of things these days. But at least I can do my part to make people understand that science is actually not optional. Okay, so what people think, okay, science is something I learn in school, and if I don't excel at it, then I have to go into liberal arts or something. Please, this is just bad teachers. The reality is, if you know the Pavlovian dog experiment, that's science. So you ring the bell and then you give the dog food. Well, guess what? Now the dogs at some point learn bell means food. That's a prediction. And that obviously is, this observation leads to this future, right? That obviously is already science. So even dogs, do simple amounts of science. And so we cultivated it as humans. And so basically we push it forward. And why do we do this? Well, because it helps society, and it helps us beat evolution ultimately, right? Ultimately, I have this joke. I say, what if there was a method that would actually prolong your life and it would be right in front of you, but most people ignore it? The method is called science, right? That's actually what science is. And so naturally I'm very into obviously teaching that. I'm also I'm a proponent of teaching computer science a little differently than it's currently taught. Most people, when they think of computer science, think of programming, and of course that's the thing that makes people money right now. Sure. But it's interesting because we forgot that it's actually a science, and lots of the things we do should fit into this sort of what I call the scientific canon, where basically, it's. I give you an example out of machine learning. So, for example, you can ask many people. So when you have an artificial neuron, right? So we use the dot product as a threshold there, right? So the neuron fires if the dot product is greater than some value, and you ask people, why the dot product? There could be all kinds of ways we calculate this. Why the dot product? And it's interesting that many machine learning researchers give you answers like, because we need to decorrelate, or that's just what it is, or we need to model a hyperplane. All of these things are not wrong. But the real answer is that the dot product is a geometric interpretation of energy. And of course, a neuron is an energy threshold, because you want to think about your left pinky toe only if I step on it, or I mention it, that's obviously a different one. But reality is we have so many sensors all over our body. And of course, what a neuron really does is ignore information, right? Basically thresholding the information, only having your attention focus on stuff that matters.
Well, otherwise we wouldn't be able to function.
Otherwise, there would be no way to function. And there are all kinds of diseases where your neurons fire too much, and then you have to do something about it.
This wasn't planned, but it brings up an interesting thought in my mind. Have you studied, so people with autism, for example, have a high level of sensitivity, most of them, many of them, a high level of sensory sensitivity. Is that related to what you're saying, or have you thought about that?
So I mostly really work with artificial neural networks, right? Or artificial intelligence, basically. But I more and more start to see that there are these parallels, and I cannot give you the answer for it, but I'm pretty sure that the more we understand about artificial, we will also understand about the real game. And it seems to me the right way to go. Often people think, no, we do brain first, then we do artificial. I think artificial first, then brain is probably easier. But, we can just debate and discuss that, right? That's just an opinion.
So were you the type of kid that asked why questions all the time?
Absolutely. Well, yeah. So why questions are the most important questions. And unfortunately, I feel like they have been suppressed, especially in this World War II generation, right? Because if you have to fight 2 world wars, then of course you shouldn't answer. I mean, basically, why do I shoot these people is a bad question, right? It's a good question, obviously, but not in that moment and when we had World War II. And so unfortunately, even because much of the science was military driven, it seems to me that it was suppressed. Why questions were suppressed. And I absolutely encourage people to ask why questions. And yes, it leads to the next why question and the next why question and the next why question. And that's okay, because that gives you depth.
Yeah. Back to AI, I'm curious what your thoughts are. Have you been following what Elon Musk is doing in Neuralink?
I haven't been following a lot of this because unfortunately, so I started working on artificial intelligence and neural networks in 2001.
That was a long time ago.
Way before they were in any way popular, okay? And what happened is we knew about all these things that don't work with them, like hyperparameter tuning, for example. You actually have to sometimes choose more parameters randomly to start with than you're trying to learn. I mean, it's just like, it's very bad. And so we were like, okay, yeah, that's research. That's cool. Let's work on this. And then at some point, industry, I think Google, Microsoft et al. Made this a product. but without fixing any of the things. And so now we have 1 million expert opinions on what it should be. But unfortunately, what I don't see and what I'm trying to push personally is a scientific approach to these things, right? Just like, it's an energy threshold. So what do we know about energy thresholds, right? As we combine energy thresholds, you will see that chemistry has a lot to say about energy absorption, for example. So the point here is there's a lot of knowledge that we could borrow left and right from different disciplines, but no, rather we reinvent the wheel and try to not think about these things, but it's much nicer to be popular, because if you say the word machine learning and if you say the word artificial intelligence, then people tend to listen. But unfortunately, I have bad news, because I'm there to dispel the magic. That's what scientists do, right? It sounds like magic, but the point is, no, what scientists do is they dispel the magic and they go in and make things, measurable, for example. And that's actually the big part of my work that I'm doing right now. So I don't understand why, when an engineer builds an airplane, a car, a kitchen, a house, a bridge, whatever, you name it, it starts with measurements. When you go to I don't know, I'm just gonna say the brand Home Depot and want to remodel your kitchen, they're gonna ask you for measurements first.
Yeah.
But how is it that when we build a model, nobody does measurements first?
Why do they not?
Well, because the measurements are not known, and also there's incentive to just use the biggest model possible, because people like Google and Amazon and others are paid for the computational power. So the more overhead it takes, the better for them.
So there's misalignment in incentives.
There's misalignment in incentives. Usually that's the cause for many things. And the other thing is that there's also a lack of knowledge. For some reason, while there's so much theory out there for so many things, for machine learning, we actually have a lack of theory. Because, and I tell my students, please go read the books from 30 years ago, because they had a lot more theory and they were a lot more founded than modern books on artificial intelligence. They just treat all the sort of artificial intelligence like a black box, like, oh, we can't understand that either because it's intelligent. No, of course we can. We build those things. Why don't we just build neural networks, just like we build bridges? And of course, that's not only my class at UC Berkeley, it's experimental design on machine learning, but it's also my company, where we started to automate the process using information measurements.
I want to hear a lot more about Brainome, but real quick, while it's on the tip of my mind, I want to ask you, like, what do you see, what would you predict in the, what would we say, like, evolution of AI and machine learning in the next 5, 10, 15, 20 years? Where are we headed?
Well, so I think, unfortunately, there's only two possible outcomes that I can see. One is we're going into winter again because the hype is over and we didn't solve the problems that we should have solved. That's one way. And we hope that doesn't happen again. The other way is that we become a lot more rational about these things and start to think about like engineering discipline. And of course, I think I see some of these movements like ML ops and so on. We start to become more reasonable about things. But the reality is that so far, and this is sort of my goal, is to make building models an engineering discipline. We know so much about model building from physics, for example. I mean, the first model builder was Isaac Newton, okay? So he modeled the apple falling from the tree. Perfect. So why don't we use the principles we learned there, for example, Occam's razor, you mentioned it, to do that. And if you ask Google for why is the GPT-3 model so big, they give you all kinds of answers, but the real answer should be, it shouldn't be so big. It should be a lot smaller. Okay. And there's a bunch of academics who agree with me on this, by the way.
Okay. So bringing this down kind of to the ground level, what do you see as the practical application, not for scientists like yourself, but for end users of AI technology? Where are we headed in terms of societal application?
Yeah, so I have to make a quick distinction between machine learning and AI. Okay. So most topics I was talking about were machine learning. Okay. Machine learning is we train a finite state machine, instead of training a brain. Finite state machine is your laptop with whatever algorithm, whether it's a neural network, a random forest, or whatever you come up with. We train that to do some task, and the trick is to not do that by hand, by programming, but to do that automatically, right? So basically just showing it sample, right? And so for machine learning, what I see is the complete automatization. In fact, that's what my company Brainome is heading to, where you basically, instead of just guessing and checking different models, no, you build them based on information measurements, just like an engineer. That's what I see there. And now that you have machine learning and it's easy to use, then our next goal is to make that basically, because again, our models are like 3 orders of magnitude smaller than whatever I've seen from Google or SageMaker and so on. And they also train 2 orders of magnitude faster. Then you can put that into Excel, or you can put that so that everybody can use it, because that's always been the major point, that you get this out to everybody. And the interesting part now is the moment you put that actually into something like a spreadsheet, your question would be, okay, but why does somebody care? Well, it turns out the moment you put machine learning into a spreadsheet, you can do what if questions, like what if I change this value, what the prediction then be? And these what if questions then obviously become like an expert. They're like, if I'm asking you, well, what if, the podcast takes too long, or what if my answer is this, right? This is, you are the expert on this, and I'm the expert on other stuff. But then based on your data, the what if questions in a table could become basically an AI for everybody. And what I learned doing my startup is you can't actually really sell machine learning, but what you can sell is AI. Because that actually is sort of, once you replace sort of a human expert in something, that's value, obviously, because the human expert would otherwise cost money.
Right. Yeah, and it's not nearly as scalable, or not as easily scalable. Okay, so Brainome, you're the CTO, co-founder, kicked off, looks like about 2 years ago, right? Tell me more about that. Like, what do you all do, and who's the audience that you serve?
Yeah, so basically what happened there is, again, I've been doing AI since 2001. So, oh my God, that's 20 years now. Oof. It's the first time I think about that. Oof. Okay, anyway, it doesn't matter. For 20 years. And for the last couple of years, my biggest problem was that while I was happy doing AI the way I was doing AI and machine learning, I then figured out something is wrong. Everything is anecdotal, right? Everything we hear from is like the success story here, the success story there, and it doesn't feel like it automatically translates, right? So for example, I think a prominent example is IBM Watson. Whatever came out of it? Where was the translation from something that Watson did to something more general that's useful in a product, right? It kind of is all anecdotal. And I said, why is it that it's all anecdotal? And it turns out we look at history. In history, something that was anecdotal before was alchemy, right? They figured out, oh, if I do this substance and this substance, that happened. But there was no general framework for it. And it turns out, yeah, that had to be developed. So alchemy became chemistry. And this is what I see here too. This is what I started working on. My theory that would generalize, that would generally tell you how machine learning works. How do you measure your data? How do you measure that you have enough data? How do you measure that your model that you selected is actually the right model for this particular task? How do you measure the size of the model that you would need to comprehend that data, and so on? This is the theory. And I worked on this theory for about 3 years. And now I'm actually writing this up, as a textbook as well. But apart from that, I was like, no, theory is one thing, and theories can be on a bookshelf for a long, long time. I really want to make this real. And so I found, a couple of initial investors, and we started Brainome. And Brainome actually makes this really real, because what it does is it's basically like, it's 2 tools in one. One is a measurement tool. So it gives you all this information about, do I have enough data? And which machine learner should I use? Or is this kind of feature set better than this other feature set? This is a measurement tool. But it also will automatically build a model bespoke to your data based on those measurements. And so it acts like a compiler, literally, comma separated value file in, predictor out. And right now we're creating Python predictors, okay? But so basically, it becomes an automatic process. And of course, AutoML is claiming they do the same, but they don't, because what they do is they try all the models on Earth that they know and hope that some of them fits. Well, we actually build those models based on information measurements to your data. basically neuron by neuron or decision branch by decision branch. And that's exactly like an engineer would build your kitchen, right?
I see. Yeah. So who is your customer?
Yeah, so we have different customers. First of all, there's a free version out that everybody can try. You just do pip install Brainome and go ahead and try it. Okay. The second thing is we research institutions. So because here's what happens: there is a lot of data scientists needed, but not enough data scientists out there. So we enable, for example, biologists to just run machine learning on their data, so to see what's going on there, right? And also in particular, we actually a pretty good tool for that, because we don't have a problem with the curse of dimensionality. It turns out when you have very high dimensional problems, things change, but because we measure things out, we know that they change and we'll act accordingly. And so lots of basically bio-research institutions. I'm not sure if I can say the names, but you know.
Oh, no, I wasn't looking for names, just in general. Yeah, who you're serving.
Basically, yeah, it's scientific. They also like the fact that it's reproducible, right? Every time you run the tool, you get the same result. All of these, and of course, I'm not surprised. As I said earlier, I'm a fundamentalist scientist, and so of course we resonate well with those people, because they like, that this stuff is rigorous.
Yeah, absolutely. So what is your current biggest pain point at Brainome, or biggest challenge?
I think my biggest challenge is to, first of all, as a startup, always outreach, right? We are small, everybody else is big. Okay, that's number one. And of course, I'm happy to be on a podcast here for that. But the other pain point is obviously misinformation, right? So the issue is that Google, NVIDIA, and so on, they have incentive to have people think that there's no data like more data. It's wrong. It's easily wrong. And I can show it to you in a minute if you want. It's a very simple proof that there's no data like more data is absolutely wrong. Okay. And then there's easy incentive to say, oh yeah, there's going to be a linear increase in the model size of natural language processing models because GPT-3 is so big. No, you want a linear increase, but you want to sell more hardware. But the reality is these models can be 2 or 3 orders of magnitude smaller. And there are proofs in my lecture and soon in my book that, first of all, we know from 1956 Kolmogorov that 3 layers are enough. Deep learning isn't necessary, really. You only need 3 layers. And the next thing is the hidden layer only has to be logarithmic in size compared to the number of instances that you look at. So these networks can be extremely small. So why is deep learning interesting? Well, because the training methods don't work so well. So we have sort of, this helps with training. But the other thing is that obviously for images particular, or any sensor data, you have a lot of noise. And so they use convolution in the beginning, but that's not new. We had image pyramids for decades, right? And so, as I said, there's a lot of hype on misinformation, even in that area, because it's like, oh, deep learning is the solution to everything. No, deep learning is a very special solution for image recognition, and then also particular images, by the way. And you have to adopt whatever you do to whatever you do anyway. But yeah, let's call it deep learning, right? So
it's like no area is immune to misinformation.
Exactly.
It's like, golly, and it's an uphill battle, I'm sure, for you and your team to educate even people already familiar with this, to say, like, it's kind of like the idea of like stopping to ask yourself as a founder, is my ladder even leaning up the right wall, right? It's like, am I even working on the right thing? And that's got to be a challenge for you all to change people's mindset and paradigm in the way that they look at this in general.
Well, the interesting part is there are two ways of doing. One is, again, junior people immediately get it. They're like, what they tell me here about machine learning seems way too empirical. This is a systematic approach. I get that. So my students, my class at Berkeley it started 2018 with 7 students. Then we had 2019, we had 20 students. I'm going to discount 2020 because, 2020 didn't happen. Yeah. But 2021, this has 98 students. So It's basically super exponential growth, because people realize, oh my God, systematic knowledge about machine learning, how cool is that? And yeah, I mean, it's human nature to be systematic, and it saves so much work, right? And it saves so much compute as well. But again, the incentives aren't there. Having said that, I strongly believe that this is not, it was never sustainable. To waste was never sustainable. And so the moment people realize that this is so much easier, that you can rerun 5 million samples like Higgs boson detection on my 2012 laptop. And the original research was like on a compute cluster. Come on, right? So it will, you know, I'm a fundamentalist scientist, so I think it will prevail. It's just a matter of when. But the other set of people that seem to get it are actually, funny enough, the absolute high rank. So like if you go really up high, like, you know, the head of one of these research institutes, they get it immediately. They're all like, yeah, looking from a big picture. So it's both the people who are introduced to it, they're like, oh yeah, this makes so much more sense than all the other introductions. And then the people up high who've seen it all and say, oh my God, finally somebody's doing the right thing.
Because they're looking at it from a bigger picture lens.
Yes, exactly. So big picture people usually get it. The worst are the people who just did their data science degree and just learned in this. And you go like, I'm sorry, it's not redoing everything. It's just, you know, there's an extra part to it that will save you a lot of work. But, you know, they get paid to tune hyperparameters. And I'm like, I know, but I don't like to tune hyperparameters. I don't know. I like to ask the right questions. That's what I like to do as a scientist.
Why are you're obviously extraordinarily passionate about this. You stuck with it for more than 20 years. Why? Like, why are you so passionate about this as a pursuit?
It is actually almost spooky, because if you think about this, what did we do before? What we did before was before machine learning, right? And before computers, what we did before is we had a phenomenon, right? We had to look at a phenomenon and try to understand it. The way to understand it is you measure it out. You have experimental conditions, right? Let's say you're testing, you know, a vaccine. Well, there's age, there's gender, there's, I don't know, body mass, whatever you can come up with. And then you give the vaccine and you ask immune, yes or no, after, I don't know, 6 months, right? So you create this long table of things. And the interesting part is that the original work of a scientist was to look at the table and finally come up with a formula and make the decision. Well, what we do right now is we take that table and give it to the computer, come up with something and make that decision. So I, again, as a go and say, well, that means that we're going to replace Einstein's brain with a machine. And it's interesting. Who's famous now? Not the researchers anymore. It's GPT-3.
Yeah.
Right? It's not right. I'm sorry. So the major point is, first of all, I think obviously machine learning should help us augment the scientific decision. I'm completely for it. But GPT-3 is kind of replacing it, and it's now magic. And it's like, no, as a scientist, I first of all am there to dispel the magic. And second, let's do it right. Let's have the computer come up with models that actually augment the scientific process so that we understand what's going on, right? Let's find out why. Let's have the computer answer the why questions. Again, coming back to those. And, you know, ask anybody at Google, why does GPT-3 work? The answer is, oh, because Google is awesome, right? It's like, that's the answer. No, this is not a scientific answer, right?
Right.
You trained it with so much data, okay. Did you overfit it? Would it work with anything else, just as a lookup table? Good question, right? None of these baseline experiments have been conducted, right? So we need to get away from this, and we need to get back to the rigor. And guess what? I think if we do that, then we will also convince more people who don't believe in science to believe in science. Because another stick, for example, that I have is math education, right? Most of our lives we spent doing calculus in high school. And it's really interesting is I say the same about PE. Most of my life I spent doing track and field. I'm not good at track and field, but in my adult life, I ran marathons. You know, I have a third dan in Taekwondo. I don't think I'm not a sporty person. I actually am quite fit. But of course, if the only discipline I need to learn in PE is track and field, well, and I'm not good at that particular one, guess what? Then you'll hate sports for the rest of your life. And this is the same with math. Math has so many disciplines, but we need to put on calculus on people just because of, well, tradition. It turns out calculus is actually not so very good when you try to deal with computers. because anything in calculus, like an integral or a differential equation, can only be guessed and checked against. You use Monte Carlo simulations. Rather, if we taught discrete math, if we taught information theory, if we taught, more statistics, stuff that is more amenable to computing, to automatic computing, even logic should be taught absolutely in school. Then guess what? Then people would see, oh, math is so many disciplines, and just because I like this one, it doesn't mean I don't like all of it, right?
Yeah. Tradition is such an incredibly powerful force, and it's beautiful in a lot of ways, but it's unfortunate, or it plays out in an unfortunate way in many circumstances, including what you're saying here. And I think we can broadly apply that idea to lots of different areas of life. And it's kind of overwhelming and a little depressing to think about fighting against tradition to get people to view things with a new lens, including everything that you've been talking about. It's like, that's honestly got to be a little bit overwhelming for you, right? It's like,
well, so the interesting part is I tend to remind people, especially working in artificial intelligence, you have to go with a working definition of intelligence, right? And so the trick is, if I'm going to say one, and of course people are going to say, but, okay, you can say your buts. But the working definition of intelligence for me, and it works really well in my entire theory framework, is intelligence is the ability to adapt to changing goals. And the trick here is that makes a smartphone smart, right? Because now you can have an app and your goal is a different one, right? And the trick here is that it's the same as resilience, right? Now a virus comes along, well, let's adapt. Like, all the waiters had to be Uber drivers or something, right? So that's intelligence. They had to adapt to, survival is still there, but how do I do this now? How do I, and that's actually what really, really makes intelligent people, to adapt and to see mistakes and to just correct them.
Where does wisdom factor in? Because if I'm a waiter and I can see what's happening, like I still have to discern that and apply some level of wisdom to decide to make that change, period. And then, when to make that change. So how do you factor that in?
Well, so there's different levels of knowledge, right? One is anecdotal knowledge that is really just temporary, right?
Okay.
But then there's also fundamental knowledge. Fundamental knowledge is knowledge that never changes. Typical examples in science is thermodynamics. Thermodynamics, I call the constitution of science. Okay. You can create whatever law you want, but if it goes against thermodynamics, you get into trouble.
Okay.
Okay. It's just like a president. You can try every law you want, but you can't go against the constitution. And that's the trick. Uncertainty always goes up, period. Okay. If you don't see that, you didn't see it right. And there's a bunch of things that are completely fundamental, and I would call these wisdom. And I would also make sure that the fundamental knowledge gets taught first. And I don't understand why we don't do that, right? So why don't we start with the fundamentals, and then you can branch off in your specials? But it has to do, I think, with how humans grow up. They want to be productive as fast as they can. So it's much easier to teach them what's currently at the edge so they can get into a job.
Yeah.
But as people grow older, they figure out, oh my God, if I just now I have to derive the fundamentals by myself. If I just learned that earlier, that it would have saved me so much time.
Yeah. Makes you think of first principles.
Wisdom. Exactly.
Just in general.
Yeah.
How do you apply that when like you mentioned productivity? And one of the themes that I like to think a lot about and discuss on the show and just with other people is this idea of productivity and how we measure that in our modern way of work. And I recognize that there were periods historically where productivity was measured in a very precise, finite way. You're working on the assembly line, you assemble X number of widgets in Y number of hours or whatever. How do you think of that now, especially in the position of a founder, when you have to evaluate at the end of the day, did I contribute something towards the goal today? Did I move the ball down the field? Like, how do you evaluate what is and what is not productive in your daily life as a founder?
That's a very good question. Of course, the unfortunate standard measure of productivity is money, right? But then also we know time is money and so on. And funnily enough, if you ask Einstein, time doesn't actually exist. Okay, so time is a virtual dimension that humans created. Well, so is money, obviously. But if you really think about it from a fundamental, and I think that's where your question goes about, from a fundamental wisdom standpoint, it would be, how much uncertainty did you reduce for somebody. Okay, so it could be anything. It could be a nurse, and of course that person that's sick that you're caring for, without you would be completely lost. It would be uncertain if they survive even. But with the nurse, she helps that person, and it's like amazing, right? Or you could be a bank. A simple service is a bank is simplest service of uncertainty, where it's like, oh, guess what? You put the money with us, and you don't have to worry about anymore. Where you put it into like chests or something. You know, we get to like video games where you open the random people's chest, right? The same things actually happen this way. And you can think of whatever profession you can think of. It's ultimately you reduce somebody else's uncertainty as a service. Okay. It's like, how do I get from A to B? Well, I call an Uber. No, that is an uncertainty reduction, right? And then the actual productivity is to do it.
I can hear that you speak a lot in fundamentals in kind of ethereal language. Is it hard for you to, like, when it comes to implementation, boots on the ground, taking action, or do you find that you have a nice balance between the two?
That's I love this question. I go between different modes. Okay. And so for me, for example, it's interesting when I run or when I take a shower, when I have my brain in the right mode, I think in fundamentals. I literally do the thing sometimes also where, you know, I don't know, the Queen's Gambit on Netflix, where she moves the chess figures.
Yeah. It's a great, great show, by the way.
I do that with math sometimes when I have questions like that. But in other ways, if sometimes I'm grumpy that things don't get done. And so I just go boots on the ground and get them done. Usually when I'm in that mode, I'm really fast, and then nobody disturbs me. And then I'm like, boom, like just let me do it. Okay. So most of Brainome's code, I've actually written myself. Okay. So now, of course, we have more people and so on, and I'm becoming more of an actual CTO role, and it's more like strategic and fundamentals and what's the next step and so on. But in the beginning, no, I totally wrote the first, 10,000 at least lines of code for Brainome. Absolutely. Also, I enjoy that. I mean, it's ultimately how it all started. Right?
Yeah, that makes sense. I think the founders that are ultimately successful either have that natural or a nice blend between those two elements that you just described, else they partner with somebody that complements them where they're deficient. Yeah. I'm curious, like, I know that you're partnered, you have a co-founder. Do you find that you two complement each other well in
yes.
these different areas?
Yeah. So we had a company first where we created this speech recognition board that you can program freely without the internet. So basically Alexa without spying on you. It's called Movi. Just use more advertisement since it's for Arduino. Okay. But the interesting part is that doing that company, I realized, oh, wow, like, one thing is, I basically built the whole thing, software and hardware, by myself. Just, I wanted the kick of being on Kickstarter, and so I got that kick, and it was really cool. And honestly, both were like, while this Kickstarter numbers were going up, that was like, I don't think any other drug could have given us that high. That was unbelievable when you have Kickstarter. It's just an extreme interesting experience. Anyway. And on the other hand, though, he kept me grounded. He was like, okay, so we have this amount of money. It's some money, but it's not infinite money. And then also there's a timeline, and let's make sure the timeline fits. And, there's all these laws here. We have to pay sales tax and all of these kind of things. And that was really good because I definitely did not want to pay attention to these kind of things. And so, yeah, there was absolutely complementary in that way. And I think he appreciated that he learned a lot from me technically. And I appreciated that I could rely on him, he being a rock on, like, going to the lawyer, creating terms of service. Like, right, you need that, right? Stuff like that. He just did, right?
Great. So would you recommend to founders that they have a co-founder?
Oh, absolutely. I actually recommended, I would even go and say I recommend a team of 3. Because
why is that?
It breaks ties, right? It's because you both think you're right when there's and there's something. And even if the decision ends up being wrong, if 2 people stood behind it, as 2 people, they may have an easier time saying, okay, that was wrong, let's go somewhere else, right? I think 3 is optimal, but I also realize it's not always easy to find 3. That's why I started with 2 as well. But also was suggested by various founders, get a 3rd person. It kind of makes sense.
Yeah, it does. This is obviously very anecdotal, but we've interviewed somewhere in the range of 160 plus founders on the Fuse show, and the vast majority of those have a co-founder. These are generally funded companies, not always, but generally. And I could probably count on one hand how many are solo founders. So it's interesting that it most often plays out in the way that you're describing, with at least two.
Yeah, and I think, I mean, I get that some people just want to do it all, but really your life it's hard enough in a startup. So it's much easier, you know, to have a number two. And really, if you hit it big, it doesn't matter whether you even have to divide by 2 or 3, right? So,
oh, for sure. Yeah. I
it's
enjoy having, I have a co-founder, and we're 50-50 partners, and I enjoy having David help me carry the weight of the responsibility, because it's like we have very trusted employees that I completely trust, but there's a difference in the weight of the responsibility and that being able to be shouldered by another co-founder versus an employee. You know, it's just different. So like there's been many times where I'm like, I'm just so grateful that I can share this problem, this challenge with David, and we can bear the burden together.
Yeah, and that's exactly how I feel about, by the way, Bertrand Irisso, just to give the name. But the other thing is also life happens, right? So, you know, you get sick, or you have to grieve some loss or something. If you're by yourself, the paperwork just goes up and you don't respond to emails or whatever, right? And so having somebody else chip in then is extremely, can save the life of your company, honestly.
Yeah,
right.
I agree. Well, we are getting really close on time. I want to ask you one more question, and then we'll part ways. And that is, if you were to go back in time and give the younger version of yourself advice, pick the time, 5, 10, 15, 20 years, in the context of being a founder, and this is to benefit other founders that are listening, what advice would you give to your younger self that you've learned and maybe now implement?
Oh, the advice is I should have been an entrepreneur earlier. The advice really is, I spend a little bit too much time in, I do like research and I still do it, but I spend too much time in sort of this formalized research environment where it's write government proposals and so on. When, again, teaching is different. If you're in university, it's a very different job. But if just as a research scientist writing proposals and trying to get work done, I think I spend too much time in it. And I should have been doing a startup earlier.
What prevented you from jumping?
Oh, just to be frank, fear. It was more like, oh my God, what if I don't succeed? You know, this is comfort, right? So I'm not perfect either.
Yeah, there certainly is that risk, but there's a lot of risk, obviously, in certain professions as well. I know some are more secure than others, but that's one thing, because I have the same experience where I eventually jumped off and I had a wife and kids, and it was scary, but then I thought to myself, golly, like there's just not, I think there's this illusion in some cases of stability in the employment world. That's not, I'm not saying that it's, that entrepreneurship is, it is more risky, but still it's like, it helped to reconcile all of that to make that decision.
Yeah, and often, I mean, especially in startups, but also in regular companies, they may be 6 months away from not having money, and then of course they make it fast enough that the pipeline works. But the trick is, all they do is they don't tell the employees, right?
You just don't know.
So ultimately, you have the same job security as the founders, except the founders know about it, right? So
that's right. Yeah, that's such a good point. Well, Gerald, this has been fun. Your website is brainome.ai, so it's brainome.ai. And what's the best way for people to reach out if they want to learn more, or if they just want to say hello?
Well, there's I think a contact form on Brainome, but also there's my email address is on my website, on my personal website. So go ahead and and also LinkedIn, by the way, just put in my name, and I usually accept all contact requests. But don't spam me. If you spam me, I will still accept the contact request.
Please don't.
Not answer you.
Please don't. We get enough of that. That's for sure. Well, Gerald, thanks so much for your time. I really appreciate your willingness to spend time with us and to share your wisdom.
Thank you so much for having me. This was a really, really, really pleasant conversation. Thank you so much.
Cheers. Bye-bye.
Goodbye.